Have you ever wondered what reality looks like at the smallest scale? Quantum physics is a branch of science that explores this strange, tiny world where the rules we're used to just don't apply. At the quantum level, particles can behave in ways that seem impossible, challenging everything we thought we knew about nature. In this video, I'll introduce you to the basics of quantum physics and show you why it's one of the most mind-bending fields of science. Quantum physics is the study of the smallest things in the universe, particles like electrons, photons, and atoms. Unlike classical physics, which covers things we can see, touch, and experience, quantum physics looks at particles that are so small they don't follow the same rules. In our everyday world, if we throw a ball, we know exactly where it will land. But in the quantum world, particles behave unpredictably, following a unique set of rules that scientists are still trying to fully understand. This makes quantum physics crucial for explaining the building blocks of the universe. One of the first strange discoveries in quantum physics is something called wave-particle duality. Basically, particles like electrons can behave like both particles and waves at the same time. This was demonstrated in the famous double-slit experiment. In this experiment, scientists sent tiny particles through two slits. If particles were just particles, they should have created two clear lines, but instead, they formed a pattern that looked like waves colliding, called an interference pattern. It was as if each particle could take two paths at once and interfere with itself, which is something waves do, not particles. This dual nature of particles blew everyone's minds because it showed that particles don't just have a set location, they can spread out like waves. Now let's talk about Heisenberg's uncertainty principle. This principle says that we can't know both the position and speed of a particle precisely at the same time. If you measure one property accurately, the other becomes fuzzy, or uncertain. Imagine you're taking a photo, and you zoom in on one detail. Everything else in the background goes out of focus. Similarly, in quantum physics, the more precisely we measure where a particle is, the less we know about how fast it's going, and vice versa. This uncertainty is built into the quantum world and makes prediction nearly impossible, which is completely different from the world of classical physics where things seem certain. Another strange concept is called quantum superposition. In quantum physics, particles don't just exist in one place or state, they can exist in multiple states at the same time until they're observed. This is where Schrödinger's cat comes in. Imagine a cat in a sealed box with a vial of poison that could break open at any moment. Until someone looks inside the box, the cat is both alive and dead simultaneously. This thought experiment isn't about harming cats. It's about illustrating how a quantum particle can exist in multiple states at once until it's observed. Superposition is a key concept that enables quantum computing, where bits of information can be in multiple states at once, making calculations incredibly fast. One of the most mysterious phenomena in quantum physics is called entanglement. When two particles become entangled, they form a kind of link, and their states become connected. So, if you measure one particle, you instantly know the state of the other particle no matter how far apart they are, even if they're on opposite sides of the universe. Imagine two dice that are linked in such a way that whenever you roll one, the other one shows the exact same result, even if it's 1,000 miles away. This phenomenon, called spooky action at a distance by Einstein, suggests that particles can communicate instantaneously, which challenges our understanding of space and time. Quantum physics isn't just theoretical, it has real-world applications that are shaping our future. One exciting application is quantum computing. Traditional computers use bits that represent a 1 or a 0. But quantum computers use qubits, which can be in both states at once thanks to superposition. This means quantum computers can process complex problems much faster, making them potentially revolutionary for fields like medicine, cryptography, and artificial intelligence. Another important application is quantum cryptography, which uses the principles of quantum mechanics to create ultra-secure communication systems. In quantum cryptography, any attempt to eavesdrop on a message would instantly disrupt the quantum state and alert the sender, making it almost impossible to hack. In this video, we covered some of the core ideas of quantum physics: wave-particle duality, the uncertainty principle, superposition, and entanglement. Quantum physics may seem strange and complicated, but it shows us that there's so much more to learn about the universe than we ever imagined. As scientists continue to explore this field, we might uncover new answers and even more mysteries. Thanks for watching. If you enjoyed this introduction to quantum physics, don't forget to like and subscribe for more deep dives into the wonders of science.